Yeah, that's the one. It's too big physically.
Okay, we need to start. We do have some technical problems. For the presenter, the cable is stable. Yeah. Yeah. Okay. All right. I think we have to. So we're still setting up the presenter screen. Can somebody raise his hand in remote and so we can test the mic line? Paul, please go ahead. Can you speak? Okay, we don't hear you yet. Okay, good that we've checked this. Okay, okay. We started. Okay, so maybe we can skip the presenter slide, but the remote participant, you can't hear him. So Paul, can you? Okay, can next one, Roland? Can you speak?
Sure, I can try. Can you hear me?
Okay, yeah, we hear you. Yeah, thank you.
Okay. Maybe it's Paul's audio.
Yeah, okay. All right. Yeah, would be
Testing,
would be
testing.
would be good to have the to scan. Yeah, yeah, excellent. Yeah, yeah. Paul, can you try again? Okay, okay, okay. We get started. Yeah, okay. Another test from the room. Yeah, that one seems to work. Yeah, yeah. Okay. Okay, welcome. This is the DNS working group, DNSOP working group. And next slide, please. So the chairs, Tim Wyszynski, Suzanne, and myself, Benno. Alexander here is the so-called delegate. He's helping us with the practical issues and things of running the hybrid session. Warren is our AD, sitting in front of here. We have a Jabber scribe, which is Suzanne, and we have the note taker, the minute taker, and that's Paul Hoffman. Thank you very much. Next slide. We assume that you are all aware of the note well. Next slide. And we also like to mention the code of conduct here at the IETF. Well, the short version is be kind and be respectful to each other. If you find with your interactions on mailing list or one-on-one communications, the code of conduct is not followed, please contact the DNSOP chairs. And I also want to mention there is an ombuds team. So if you have questions and guidance and support. Okay, next slide. Yeah, so we are now running a hybrid meeting in after 2.5 years. Thanks. Yeah, I don't have the slide display in front of me. For all in-person attendees here in the room, if you want to go to the mic, maybe you already learned that yesterday, but I want to repeat it. If you go to the mic, you have to raise your hand on your telephone. So everyone in the room, even though you're not intend to go to the mic though, please register with the following quad code. because it also registers you as being as attending the DNSOP meeting. So it's the blue sheet also. Thank you. Yeah, next slide. So for the document updates, Tim or the DNSOP chairs did send an email yesterday, this morning, about the status updates. We want to keep it brief because we have a full agenda. So we'll rather reserve the time for the presenters. So next slide. We did finish DNSSEC INR considerations. It's published as an RFC, and also DNS TCP requirements has been published as an RFC. Okay, next slide, please. SVCB HTTPS service binding is still in ISG call. There are some discussion in the ISG. A new ID is asked by the ISG, and the process is going forward. Yes, next slide. Yeah, so the interims. We had scheduled 2 interims between the IETF 112 and 113, this one. It seems to work quite well for us. So we planned 1 or 2 drafts in an interim meeting of an hour, so we can discuss it in detail. It worked well for us, and we are also planning to plan 1 or 2 interim meetings between the current IETF meeting and the next one in July. Yeah, next slide. Yeah, this is important slide to mention, and if there are questions, feel free to ask. We didn't adopt any new work in the past 1.5 year. 1 year, 1.5 year. There are quite a lot of active DNSOP working group documents, and it was difficult to make progress with all documents in being active documents in the working group. So in the past year, we finished a number of the working group documents. We're in good shape. I think that the DNSOP chairs think we can go forward in adopting new work, and also Warren, our area director, think we're in good shape. So we did a survey about which working group documents were, or potential working group documents are of great interest. From the first survey 4 or 5 months ago, the DNSSEC bootstrapping and the DNSSEC automation drafts were selected as the most relevant, or they were the drafts that got the most interest from the DNSOP working group. So we will start a DNSOP call for adoption later this week for these 2 drafts. Besides that, of course, there's new work presented today. There's discussions on the mailing list. That's good, but we will have another survey for the working group to fill in, to indicate which drafts the audience, the participants find interesting and find relevant for the working group, so we can make another selection for new work. So we want to prioritize our work also in coordination or with feedback from the DNSOP working group. Yes, thank you. Maybe you want to mention something? Yeah, next slide. Yeah, indeed. It's also a word from Warren.
Huh. That screen still doesn't work.
Sorry. Yeah.
Oh, no. So Warren Kumari. So Benno and the chairs just went through like a long thing on, we should do stuff with the working group and make sure that the working group has all the consensus and blah, blah, blah. And that's a great idea. But what I would really like is if we could also do something in addition. There's been some discussion on a BCP on DNSSEC, and there was some discussion in that on maybe we just start up a really short-lived working group just to do the DNSSEC as a BCP document. And I sort of discussed that with the ISG, and there was some feedback that that sounds like a lot of admin work and faff. So what would be nice is if we could do this whole process with, the survey, and the working group has, provides advice on how we prioritize stuff. But if we could also maybe please do the BCP on DNSSEC and do that with a really high priority and bump it to the front of the queue. And so I'm sort of asking the working group for a favor of if it would mind considering that. There's been a fair bit of feedback that a BCP on DNSSEC would be good. And so, I would really like it if we could do that, do it as a fast track thing and sort of move it to the front of the queue of however we prioritize stuff. So hopefully we can do that.
Thank you, Warren. Okay, yeah. Next slide. Yeah, so document status. The document status has been sent as an email to the mailing list. If you have further questions, please contact the chairs or discuss this on the mailing list. Yeah, okay, thank you. All our work is on Data Tracker and in GitHub. So there are references and URLs also in the agenda where we organize our work. Next slide, please. So this is a little bit out of the ordinary, but it's relevant to the call for adoption of DNSSEC automation. I would like to ask Ulrich for 3 to 4 minutes. He promised. Yeah. So yeah, it's not on agenda. Yeah.
No problem. I think I know what's on the slide. Okay, hello, my name is Ulrich. I work for the Swedish Internet Registry. Yes, so you probably have heard us talk about the multi-sign-up DNSSEC automation. And one of the problems is that for multi-signer, both or several signers need to support the same algorithm. And well, if you own a domain name and if you're in the size of the Coca-Colas and stuff of this world, then you probably can persuade your service providers to support the algorithms you want. But for the rest of us, that's not the case. And so if you want to move your domains and your service providers have a distinct set of algorithms, we would need to do something to be able to move these domains. And there's, so right now the RFCs requires to be that there be signatures of all the algorithms that are in the DNS key set. And that can be done if the signers don't support all the algorithms, obviously. And so we would need to adjust the DNSSEC RFC, but we would have to do some additional work. And right now it is not really clear how to do that. And we need to discuss that. And yeah, we started some discussions on the mailing list. And I would like for more people to join in and see if we can solve this problem.
Thank you, Ulrich. Thank you. Yeah. Next slide. We're almost done. Agenda. Well, we're done. Agenda. So these are the current working group business. So it's a presentation by Dwayne in 2 minutes. And these are the other. So next slide, please. These are the new business. Are the 0-0 presentation. We do have a lot of new work in the working group because, well, the existing documents are almost finished and we are, well, discussing the details on the mailing list, but none of the presenters or authors did ask for a presentation slot. So there's a lot of new business. I won't go over the agenda. Next slide. I think we can get started. Thank you. So I would like to invite Dwayne to give his first presentation. Dwayne, do you want to run your own slides or do you prefer to?
No, I think you should do it.
Excellent.
You should do it for me.
Yeah. So that's this one. Yeah. Thank you. Please go.
All right, thanks, Benno. So this is about negative caching of DNS resolution failures.
Oh, sorry, we selected the wrong set. Thank you.
All right, I'll.
Glue not optional. It's glue not optional.
Let's do that one.
Oh, okay. We go for the negative one. Probably this one. No, they're both. Okay. Dwayne, can you?
You want me to share?
Right.
Yes, please. I think that would be easier.
Yeah.
Sorry. It seems like we uploaded the same slides twice under different titles, and now we are missing yours.
I will
Okay.
Maybe you can start. That's annoying. Blue not optional. Let's see. Yeah, it is.
Whoops.
It's fully automated, but it's apparently it's uploads.
Do you see my screen yet?
We can. You can give Dwayne permission to share his screen.
I think we're ready.
All right.
There you go. It sort of like it did start for a moment, but then it came back again.
Can you send me the slides?
Oh, there you go.
I keep getting error object cannot be found here.
Okay. Can you?
So, Dwayne, can you start?
Shall we change the order?
We change the order, but can you send me? Sorry. Can you send me your slides of the first presentation, the glue not optional? Just by
Yes.
email. Yeah.
I think I will do the negative.
Yeah.
The negative caching first.
Yeah, and then we do the negative, and I put it in the.
I'll send you both just in case.
Excellent. Yeah. Thank you.
So let's do the negative caching first, and meanwhile we work on sharing your other slide set. Sorry for that.
That's okay. It might be my fault. I just uploaded them yesterday. Okay, the mail has been sent. All right, so this is a presentation on negative caching of DNS resolution failures. This is a new draft, not adopted by the working group. Next slide. So the gist of the problem that we want to talk about today is that it appears recursive name servers are really bad at caching resolution failures, such as timeouts and server failure codes and refuse codes, validation, DNSSEC validation failures, and loops. The graphic on the right is data from VeriSign's ComNet name servers during the Facebook outage of October last year. And it shows how the rates of queries increased for those three Facebook-related domains from a reasonable amount to kind of an insane amount over the 6 or so hours of the outage. Next slide. So this list is also in the draft. These are some of the incidents and evidence of failure to cache resolution failures over the years. The Facebook outage I just mentioned, for that we saw 128 times increase in queries to ComNet name servers. In 2021, last year, myself and some VeriSign colleagues presented some work at the DNSORC meeting where we were doing some experiments with a botnet domain, and we intentionally caused one of the domains that the botnet used to return surfail errors, and we saw a 1200x increase in responses in queries to our sinkhole name servers. I suspect a lot of us are familiar with the Suname work from also 2021, and in that work they recorded a 500x increase. 2020 there was the NS attack research that was published, 1620x increase. Going back further in time, the KSK rollover during the post-revocation phase of the key rollover We observed an 80x increase in DNS key queries at the root servers. Victor Duchovny presented something at DNSOARC where he was doing a daily survey of DNSSEC, and at the end of his survey, he retried all of the names that had failed. He retried them all again, and that led to a very significant amplification effect. The Dyne attack recorded or talked about a 10x increase in retries from resolvers. And if you go back even to 2009, you may remember this paper and blog post called "Rollover and Die" from when the RIPE NCC did a rollover of some in-editor.arpa zones. Next slide. So briefly, this slide talks about the existing requirements that we were able to find in some of the RFCs. So RFC 2308 is all about negative caching, and it says that negative caching should no longer be seen as an optional part of a DNS resolver. However, it also does say that caching timeouts and caching server failures is optional. So specifically, that is something that we think needs to be updated. RFC 4697 talks about how an iterative resolver must not send a query for the NSR set of a non-responsive zone to any of the name servers for that zone's parent zone. So one of the reasons that we call out this specifically is because that is exactly what was happening in the case of the Facebook outage. Although 4697 talks about the NSR set, during the Facebook outage, we weren't exactly seeing NS queries, but we were definitely seeing queries to the parent zone for Facebook.com. 4697 also has some other should level requirements that we won't go into in this presentation. And then 8767, which is serve stale, I believe, says attempts to refresh from non-responsive or otherwise failing authoritative name servers are recommended to be done no more frequently than every 30 seconds. So again, that's sort of a should level requirement, and it's definitely not what we observe in reality. Next slide. So this is kind of what we propose in the draft for updated requirements. First, resolvers must cache all types of resolution failures for at least 5 seconds and not longer than 5 minutes. Resolvers should employ an exponential backoff algorithm in their in the amount of time that they cache negatively, or actually in back off in the sense that they retry. So every time they retry, they should retry. They should wait a longer time between retries. A resolver must not retry more than twice, meaning 3 queries in total, before considering a server unresponsive. And then lastly, we want to reiterate or strengthen the requirements about requerying parent name servers of a zone experiencing failures. Next slide. Okay, so that's it. We also presented this material sort of at the DNSOARC meeting a month or so ago, and it has a little bit more information on the background and some data. So if folks would find that interesting, I would encourage you to go look for that. Otherwise, at this point, I would like to ask for discussion and see if this is something the group is interested in taking on.
Okay. Thank you, Dwayne. I see one person in the queue. That's Paul. Not all. Sorry, Liman. Paul, please go ahead. Yeah.
Hi, Paul Wouters. If you go one slide back, I guess, you have the exponential backoff as a shoot Why is that not a must? Because that seems like the really important thing to sort of stem the flood of messages.
Well, to me, the most important thing is the at least 5 seconds, because what we see in fact is certain resolvers query like thousands of times per second in failure modes. So if we could go from thousands of times per second from once every 5 seconds, I think that would be a huge win. But I would also be willing to make exponential backoff a must level requirement if there was support for that.
Ralph Weber, I pretty much supported adopting that because I think it is important. The question is, will we get the people who are doing this with the 1,000 requests per second to actually read that? But I think we should give it a go.
Thanks, Ralph.
Okay.
So Lars Lehmann, I will just state my support for this. I think this is very important work. I'm not going to get into the details because that's going to be hashed out as we work on it, but I strongly support adopting this work to the working group. Thanks.
Thank you. Hazel, please go ahead.
Hi. So firstly, I agree that this sounds like a good idea. One thing I was wondering, you said about the 5 seconds and about you're getting thousands of queries. Part of me does wonder if, depending on the proportion of this traffic that's coming from, shall we say, large public resolver operators. I forgot to say my name at the beginning. I'm Hazel Smith. I work at Google. Is that gonna is that timeout supposed to be like per back-end task? Like, if you've got a load balancer that sprays across, I pick a number out of my hat, 10,000 backends, each of which is a name server, recursive name server, each with its own local cache. If each of those waits 5 seconds, given how many people ask for Facebook, every second of the day, is that going to be enough if each one of those waits 5 seconds, and then all of them, they all at once go, I don't know who Facebook is, better ask?
Yeah, thanks, Hazel. So it is our intention that it is per backend server, as you said. So I wouldn't. Maybe we need to be a little bit more specific in the language about that, but that is the intention. What we see today, again, if there's a large recursive operator that has thousands of backend servers, what we see at VeriSign in some of our data is we see thousands of requests per second from each of those backend servers, right? So that's how you get to 1 million queries per second, obviously. So
wow, okay.
So
yeah.
we would be very happy if each backend server could limit itself to 5 queries per second, or one query every 5 seconds. Sorry.
Super. Thanks.
Yeah.
Can I speak? Jim Reed. I strongly support this draft. I think it's much needed. So kudos to Dwayne and his colleagues for actually writing this up. I think the working group really should adopt this. I've got 1 or 2 questions though. First of all is the numbers we've got there. The saying resolvers must cache for 5 seconds and not longer than 5 minutes. I think we should have something that's a bit more evidence-based. I don't really care where these particular numbers come from, but I do think if we're going to develop this further, we should try to have an evidence-based approach to that. Maybe these values should be smaller, maybe they should be larger, I don't know. And we should consider also what the second order effects would be once those values are chosen and put into place. And the other question I have is more of a meta one, Dwayne, is that you saw there was a big spike in queries after the Facebook outage. Were you able to identify the name server implementations that were responsible for the bulk of those queries? And I would imagine they're going to be coming from a very small number because the bulk of the resolver traffic these days is coming from like Google's Quad 8 and the other all 4 services.
Yeah, thanks, Jim. So in the draft, I believe, maybe not, I don't know if it was published, but VeriSign published a blog post on the outage as well. And in there, we were able to identify some of the sources for this, right? So we were seeing a lot of the traffic coming from large recursive operators. We didn't we didn't really attempt to identify, all the open source implementations out there, but we did analysis or identification based on source address, not on, say, software version, if that makes sense.
Okay, thanks.
I can point you to that if you need it.
Sorry. Yeah, so we bumped Joao from the queue, but we do have time for a short question. Okay. Sorry, Dwayne, go ahead.
I was just going to say, if anyone needs the link to that other blog post, I'd be happy to provide it.
Okay. Thank you. So to your last request, call for adoption, we will run the survey, and your draft will certainly in the survey, so the working group can indicate their preference on their work, and we set priorities. But we will follow up on that, and we will report. We run the survey probably 1 or 2 weeks, something like that. So early April, half April, we will set out a plan for adoption of work. Yeah. Okay.
All right, great, thanks.
Okay, thank you very much. And thank you for sending us the other presentation. Not optional. Yeah, it's correct. Please go ahead.
Yeah. Okay. Thanks, Benno. So this is about the glue is not optional draft. This was originally written by Mark Andrews, and he kindly allowed myself and Shuman Huck and Paul Waters to join him as co-authors. The title originally, of course, is glue is not optional, but as we'll see, throughout this presentation, there may be need to change that title slightly. So next. The last time this work was presented, we were at revision 2 of the draft. So here are the changes summarized since then. I'm going to talk in detail about all of these in the forthcoming slides. So just go ahead to the next slide, please. So one sort of important change is that we added some clarifying text that this draft only refers to requirements on name server software implementations and doesn't really say anything at all about data placed in zones or how registries should operate. So a few people told me they were very pleased with that addition. They were concerned about how it might impact their registry operation, but that's not the intention of this draft. Next. So all references to orphan or promoted glue have been removed. This is something that was a little bit contentious before, and it seems like the group settled on just removing it. So that has been done. Next. So based on some discussions in other working groups like Deprive, it seems like we might be headed in a direction where the concept of glue could be expanding to things or record types other than A and Quad A records. So for example, there's this DS glue draft by Ben. And so the question for us becomes, should this document talk about referral glue or just continue to use the phrase glue to mean only addresses of NS records below the zone cut? At this point in the 04 version of the draft, we've gone ahead and changed glue to referral glue in most places, kind of to test the waters and see how it sounds. To me, it sounds a little strange, but we went ahead and did that. And then also, I think there's maybe a little bit of an open question about where to define glue, although maybe somebody else has some updates on this. At some point, there was talk of putting it in the DNS terminology document. And if it doesn't go there, then it seems like maybe it needs to go in this document, but I would probably not like that. So we'll see. Next. Another aspect that was controversial with the previous version was the requirements around sibling glue. So at this point, we've made sibling glue optional. And that's why the sort of strong title may need to change. But what the current version says is that when a name server generates a referral response, it should include all available glue records in the additional section. And after adding all the in-domain glue records, if not all sibling glue records fit, due to message size constraints, then the name server is not required to set TC equals 1. So therefore, we have slightly different requirements for in-domain glue and sibling glue. In-domain glue is all of in-domain glue records are required, but not all sibling glue records are required. Next. And then I think the last change that we want to talk about is that the document now talks about transports a little bit more generically. You know, it used to say if all glue records don't fit in a UDP response, then the client should use TCP. But now it says, you know, if message constraints, if size constraints prevent the inclusion of all glue records, then the client should use another transport to retrieve the full response. And next, I think that's it. Okay, so at this point, we see sort of the main outstanding issues are, you know, the phrasing of glue versus referral glue and where glue actually becomes defined. And then I think it's time for discussion.
Thank you, Dwayne. Can I invite Ben Schwartz to the mic?
Hi. I agree that the terminology around glue is kind of confusing. There are a few conflicting definitions in different RFCs. I don't really understand how referral glue clarifies, because in my view, all glue is for referral. And the things that have been contemplated in DPRIVE are about enabling secure referral, which may require more information to be conveyed in the glue. So I also don't see why those things wouldn't be subject to the same rules as everything else. So I guess I don't understand the need for this distinction. In my view, glue is whatever records have been placed in the parent for the purpose of referrals, and the parent doesn't really, it might have some opinions about what it accepts there, but once they're in, I think they should be treated uniformly.
So I kind of see what you're saying, but we already sort of have a situation now where we're treating different types of glue differently, right? Where we have sibling glue, which is different than in-domain glue. And,
yes,
so when a name server is, you know, going through and filling in the decimal section, it needs to have some sense of priority, right? Unless we're just going to say all again, go back to all types of glue.
So no, so the distinction that seems relevant there is about the location of it, as opposed to, say, the RR type. I think that if you want to draw a distinction in the draft, I think the important distinction is the location of the glue record, the owner name of the glue record relative to the other names in play.
Okay. Thanks, Ben.
Thank you. Paul Hoffman.
So because the terminology document is still open, I think it's the best place to put this. Not that I want to do the work to put it there, but I think that since we haven't closed it out, and because people writing future documents are more likely to look for it there than in some other RFC, just put it in the terminology document. We can keep it open for longer.
Okay. Thank you. Brett Carr.
So I just wanted to add my weight to the same thing, that I think the definition should be in the terminology document. As an operator who quite often has to hire new staff and bring them on board and train them in stuff, and the amount of terminology in DNS makes that quite challenging. To have one place where all that sits is really, really useful. And actually, I think that terminology document should be in constant edit. So we should be publishing it now and again, but as soon as it's published, changes happen. So it always requires updates, basically, I think.
Okay. Thank you. Ralph Weber in the room.
Yeah, so on the glue versus referral glue, I don't have an opinion. It's just words. All glue, as Ben said, is for referral. I haven't seen anything else. The other thing is the registry statement in there. I mean, registries define the name server registers, and registry kind of define the A record that's going to the zone. So if they don't need to follow this, then not sure if we're winning something here.
I'm sorry, Ralph, can you say that again?
So if you are registering a domain, the place you put the A record and quad A and name server record in is the registry. So if the registry don't need to follow this, then meaning they don't need to input the stuff, then what are we gaining? So I found that statement that the registries don't have to do something a bit weird.
So I think the impetus for this work was not about how registries behave, but it was about when a name server needs to set the truncated bit or not when things don't fit. So
the sound is very bad from your side. So it's a lot of noise or white noise on top of your voice.
Oh, I don't know why that happened. Is it still bad?
Yeah. Yeah. There's a crack on top of that. Yeah. Yeah. Yeah.
How about now?
Much better. Yeah, perfect. Yeah.
Okay, I just muted or unmuted. Well, I guess we should take that discussion to the list, Ralph, because I think the original impetus for the work was really, the behavior of name servers in whether or not they set the TC bit in their responses. And what I've heard from a few folks that work on the registry side is different registries have different modes of operation with respect to how they treat glue records or address records in their registry, and they were concerned that they would have to change their models, their registry models, and they didn't want to do that, obviously. Some have, I think it gets down to host object versus I forget what the other type is called, but there were concerns that they would have to change their registry models for this.
Yeah. Okay. Thank you. Next one, Hazel.
Hazel Smith, Google. So firstly, I would say that I think it's a good idea to make it clearer about the definitions of glue. I mean, it's possible I'm just hilariously underinformed here, but I've always struggled to know whether I should call sort of DS records that are, parent side of the zone cut, whether I should call them glue or not. And I'm sure I did try and look for a straight answer from this and couldn't find one before. So wherever this ends up, it would be good to have a straight answer somewhere, a community consensus on this point. I also hear what Paul was saying, that perhaps it should be in the terminology document. And to me, that sounds like that might be a better place for it. But as long as it goes somewhere, that's my feeling.
Thank you. Alexander in the room.
Thank you. Alexander Mayo for Nick.at. Speaking from the registry side, I think it's very important to differentiate the 3 steps between a registry accepting data, which is the first step, the second step of the zone file that a registry generates for a name server, and then the third step where the name server actually hands out a certain set of records. And I think that document should be constrained to the third step. Maybe there should be eventually a second document that talks about the second step, about what is going to go into the zone. And I would leave it up to the registry community in regex or whatever to define what actually is acceptable. And we are trying to be very liberate in what we accept in terms not to confuse our dear registrars, because they send all kind of data that we don't really put into the zone.
Thanks, Alex.
Yeah. So, Dwayne, do you have some additional questions or enough sufficient feedback?
So I think on the where the definition goes, I think we're pretty clear on that. It sounds like we're still a little bit unclear about exactly what glue means and whether referral glue, what that means. So I think that goes back to the group, to the list, and go from there.
Okay. Thank you. Thank you very much, Dwayne.
Yep.
Next up in the agenda is, I think, Ben. Yeah. Ben, do you want to run your own slides? Shall we run the slides? It's available on the Meet Echo. Oh,
yeah, I've requested.
Yeah. Just granted. Granted. Excellent. Please go ahead.
Okay. Hey, everybody. This is about a 0-0 draft that is seeking adoption in this working group. The authors are myself and my co-author, also from Google, Robert Evans. So the point of this draft is to talk about what happens when you try to do Dane and also use these new SVCB or HTTPS record types. And also it talks about how to do Dane with Quick, which I think may be maybe a major bike shed point, but is actually a very, very tiny change. So this is particularly inspired by some discussions that have been happening in dprive and also in ADD around the use of SVCB records to convey information about the about the support for encrypted transports for a DNS server, both recursive and authoritative. But it actually applies generally to things like using HTTP3 with Dane. Yeah, these things are in the same draft because they are actually connected. One of the key purposes of service bindings is to enable upgrading to Quick and skipping a TCP bootstrap step. And also, the only other way to get to Quick is using the HTTP specific alt service mechanism. So if you're not doing HTTP, then SVCB is the only way currently defined to get to Quick. So this, and also this is just a very small amount of text. Okay, I want to have some brief background about Dane, since we spent some time reading the Dane RFCs. Maybe not everybody has looked at them recently. So Dane is based on publishing TLSA queries, which contain TLS certificates or fingerprints or public key fingerprints. And those queries are made for a name of this form: underscore port dot underscore transport dot underscore base name. Or in the documents, it's sometimes called the base domain. This query follows CNAMEs as usual, and this is all very logical. It's the TLS query base domain is based on the redirected transport endpoint. It's based on the thing you're actually going to establish a socket to. Essentially, it lives as close as possible to the A and quad A records. And the Dane clients are supposed to set an SNI extension that contains this base name. Okay, simple enough, clear. But there are a few wrinkles in this design. Wrinkle one is the handling of CNAMEs. So if there is a CNAME on the base domain, the Dane specification says that the client should essentially follow that CNAME chain to its end, look at the final target name, and then append these prefix labels, look for a TLSA record. If it can't resolve a TLSA record there, it should rewind to the beginning of the CNAME chain, try a different base domain, emit another TLSA query. So there are actually two different queries for different names potentially required on every attempt to connect using Dane. That's That's an interesting wrinkle. There are also some documents describing how to use Dane with MX and SRV records, and those have their own wrinkles. So the MX and Dane specification tells clients that they actually need to maintain 3 different reference identifiers. So they should construct the base domain, put that in the SNI. So they're telling the server, I want this your certificate for this name, the base domain, but they should also accept any certificate that comes back and covers these other identifiers, even if it actually doesn't provide them with the name they were asking for in the SNI. So that's pretty weird from a TLS standpoint. And it gets even weirder in a way with SRV, where SRV says that the expectation here is that the target server host name should be in the certificate, but clients should not ask for it. They should ask for the service name. In other words, if there's if there's SRV indirection, clients should ask for the thing before the SRV indirection, but expect the thing after the SRV indirection. Literally, don't ask for the thing that we actually expect you to get. And there's logic behind each of these decisions, but these are the considerations that sort of went into our design. So what does the draft actually say? It's really very simple. It says you do the SVCB thing and then you do the Dane thing. So the output of SVCB essentially is a list of tuples: target name, which is a concept within SVCB, transport, and port number. And so this draft just says you take those tuples and you treat each of them totally independently as an input to plain old basic Dane. So that is very much like the SRV specification. We tried to stick close to that because SVCB is very much inspired by SRV and is essentially an evolution of that idea. And but we did add some simplifications. So one of them is, there are some differences. One is there's only one reference identity. There's none of this like try to validate against one name, but if it doesn't match, here are some other names that you should also check. That seems like it will significantly simplify implementation when using common SSL type libraries. But there is also another difference, which is that SRV records prohibit the use of CNAMEs after the SRV indirection. SVCB does not, and even mentions it in the draft as something that you can do, I think. So wrinkle 1 still applies here. But ideally, that's sort of hidden within the abstraction that identifies Dane. That's within the Dane black box. The other thing that this draft says, and this is literally the entire text of the section, is to update RFC 6698, that's the original Dane specification, or well, that's an early Dane specification, with a different definition of what the transport prefix labels mean. And the key here is that the current text just says TCP, UDP, and SCTP. And this raises a question about what happens if you have DTLS and QUIC running on the same endpoint. DTLS and QUIC are demuxable at the transport layer. So there's no absolutely necessary reason why they would have to have the same certificate or the same key material serving both of them if they were both operational. But maybe more importantly than that is that there have been some proposals to use the presence of a TLSA record to indicate which transport is in use. And so if you are trying to tell the client whether to use, or if the client is trying to ask, does this server support DTLS? we'd like the TLSA record to be unambiguous. The presence of a TLSA record for UDP should be an unambiguous indicator that the server supports DTLS. And it has been right up until the publication of Quick. And then now it's sort of a little unclear. So the goal is to remove this ambiguity and also sharpen the semantics here, essentially arguing that these so-called transport names are really about the immediate underlying protocol below TLS, the protocol that contains the TLS handshake. Here's just a quick example of the kind of thing that motivates this. So if you imagine you have a DNS server, again, maybe authoritative, maybe recursive, doesn't actually matter very much for this. And it's got some set of service bindings, including some advertisements for DNS over TLS and DNS over Quick, maybe on different ports. Then these are the TLSA records that you would have to publish to go along with them. So this is a very simple draft. We're seeking adoption in the working group. I'm happy to answer any questions about it.
Thank you, Ben. Yeah, we do have time for questions. Wes, please go ahead.
Oh yes, my video is upside down.
Oh,
Good.
there we go.
Wow.
That works well because of the topic in question. So the reason that Dane chases the target is who is in control of the certificate in particular, right? So the one thing that you should definitely consider in your draft is, think about it this way. If I'm the owner of a website and I have a CNAME to my CDN, right? I do not want to do the Dane updating of a TLSA record to keep tracking the CDN certificate as it changes. You don't want 1 million customers potentially getting those TLSA records wrong. Yeah. So the reason for the Dane chasing is that, but still allows that, if the CDN actually doesn't have a TLSA record because they don't support TLSA, then I can publish one anyway, right? I can work around it. So that's sort of the.
Of course, you could always do that by if you're willing to copy paste their IP addresses into your zone as well.
Well, so right, that's always the problem, right? That you want to do the least amount of management possible. So following to the target is quintessentially the purpose. So you definitely want to do something. Point being, regardless of why Dane does it right, you need to be able to account for the fact that zone owners do not necessarily want to do a whole lot of tracking of remote certificates. That's a real pain.
So I think that we are doing the thing that pushes furthest in that direction. Yes, I agree with that.
Okay, thank you. So Wes, you're looking much younger upside down. I think I will follow your example next time.
I'll have to start walking around that way.
Samuel Weiler, please go ahead. We can't hear you. No. Sam, we don't hear you. Sam, we don't hear you.
I can see you.
Yeah. No. Okay. Sam, you can also type in your question, and Suzanne can relay that, or we can relay that to the room. Okay. Okay, well, for timekeeping, Ben, some final words, call for adoption.
I'll just, so this is a call for, but this is a request for adoption. So please consider whether you'd like to see this work in DNSOP. We've had some discussion on the mailing list, mostly about this last point about wrinkle 1 and C names, with some argument that this maybe should actually be deprecated across all of Dane, and that as a first step we should not permit it here. So essentially, the client would follow CNAME chains to the end and would only do a single TLSA query for the final alias target name, not rolling back to the beginning of the CNAME chain.
Okay. Thank you. Thank you. Okay, next presenter is Willem Torop in room.
William, unfortunately, that screen doesn't work, so you can either. You'll need to resort to that one.
Okay.
If that's good for you.
Yes. Well, let's have a look. So I also asked to.
Yeah, I granted you access. So.
Well, this is fine too. I'll just say.
Move a little bit closer to the microphone, or you can also sit here if you like.
No, that's okay. I just need to. I can't read. I need to read this text. Okay. So this is new work. Also, maybe looking for adoption or at least get feedback from you to see if you like this idea. Dry run DNSSEC. A dry run or a practice run is a testing process where the effects of a possible failure are intentionally mitigated, according to Wikipedia. So on the picture, you see the Italian astronaut Samantha Cristoforetti doing a dry run of a fix of the International Space Station in a swimming pool. This work is, I'm doing this work with Yorgos Thessalonikas, which is the Unbound developer at NLNet Labs, and Roy Arends. Next slide.
Where's the next slide?
You should be able to do that.
Oh, should I? Yeah. Oh. How? Oh, yes.
Yeah.
Oh. Well, yeah, but that's.
Yeah, now you can't see.
It's either way. Okay.
I can forward the slides for you, so I'm gonna share them. Sorry, guys.
Okay. Can you forward the slides with me? Yeah. Okay.
But you need to stop sharing the slides so that I can start for whatever reason.
Okay, I stopped.
Very good. So we are on slide 2 now with the table.
So DNSSEC deployment is lagging. The top level domains are signed for 90%, more than 90%, but second level domains are not. Here's an overview of the top 10 largest domains. So some of them have even 0 signed domains or are not signed themselves, I suppose. And next slide, please. So why will people deploy DNSSEC? So one of the thoughts has been that Dane would be a driver of DNSSEC. This is a slide from a presentation given at the last DNS.org showing the amount of Dane deployment for mail exchange. And you can see that the only domain where Dane deployment is really taking off is .nl. And .nl already has a large DNSSEC signed population of domains because there's a financial incentive. Basically in .nl, if you do DNSSEC on your domain, you get it for cheaper. Next slide. So the other reasons for DNSSEC to lag behind a little bit is that DNSSEC failure appear as network failures, which is not nice. You cannot see that it's something with DNSSEC. Next slide. And also, enabling DNSSEC is not without risks. There are unforeseen failures. I'm showing here the picture of a report of the recent failure with Slack, and they actually did dry run their DNSSEC deployment, but still managed to, be off the grid for the TTL time that the DS had in the parent. Next slide. So there have been efforts to mitigate this. One very nice one is the extended DNS errors. Instead of DNSSEC failure appearing as a network failure, it will show you the actual error. Next slide. Here you see a query for dnssecfailure.org, I believe. And the EDE, or the EDNS extension with the extended error, saying something is not good with your SEP record or something. Next slide. And this is a call out to Mozilla, because this is Firefox running DO to Cloudflare that does provide the EDE code, but Mozilla is not displaying it. Why not? Now this is important. Next slide. And recently, Roy Arends came with a new draft, the extended DNS error reporting, which is not only conveying the error to the client querying the name, but also to the reporting agent of the operators running the domain, which is good because they can then fix it. Next slide. But unfortunately, the error has then already happened. So the extended DNS error reporting is really good, but it happens after the fact. So what is dry run DNSSEC? Next slide. Is get the DNS error reports, but then without the end user experiencing the failure. So operators can try out DNSSEC deployments for a period of time before rolling to actual DNSSEC. Next slide. So this is conveniently signaled with a new special DS algorithm. Next slide. The idea is to put the DS algorithm, or what the DS algorithm would have been in an actual DNSSEC, as the first byte in the digest field, and the digest just following after that. Next slide. So here you see what the DS record for IETF.org and how that would look like in dry run DNSSEC. So it's the digest type field is changed from 1 to dry run and moved to the first byte of inserted basically into the digest. Next slide. So the idea then is for resolvers to look at the DS resource record set. And so if there is no DSRR set, it's insecure, of course. But then if there is a DS set, a validating resolver has to pick a DS. It will choose to validate the domain. In this case, it will look, is there a dry run DS? If so, we are going to try that first. Then, does it validate? Yes. Great. You return the answer with the AD bit set. If not, send the report to the reporting agent of the operator following extended DNS error reporting. And then do the validation again, but with pretending that there had not been dry run DS records in the parent. So if dry run DS is your only DS record in the parent, it will fall back to insecure.
Willem, do you want to take questions right now because we have Paul in the queue, or afterwards? Or? Okay, fair enough.
Continue. This flowchart is because it conveys the ID easiest, but in actual implementation, one of the authors is Yorgos Thessalonikev, which is the developer of the unbound recursive resolver. What we actually want to do is take a dry run DS and a non-dry run DS simultaneously in the validation process, and then evaluate them simultaneously, and also have two security statuses with the RR set in the cache, because otherwise it will be, it would be like a bit complicated for implementations. It would be another straw on the camel, I suppose. Next slide. So this also enables opportunistic Dane. If you have Dane, excellent. If not, then So not useful for signaling, right? Which as it happens with mail, for example. Next slide. Is this backwards compatible with existing deployments? Yes, because the spec says if a validating resolver does not recognize the DS algorithm, it should just ignore the DS altogether. Next slide. So another colleague of mine, Tom Carpay, did some measurements during the hackathon, trying to determine what the effect is in the real world of having a DS record with a strange digest type. And there were some issues with Wipe Atlas at the moment, but we could, the results for running driver next to actual DNSSEC deployment, that was done. And as you can see, the error margin is larger than the actual effect. Next slide. CDS works as before. We think it's perfectly fine to bootstrap actual DNSSEC from dry run DNSSEC by having a CDS key in your zone. CDNS key, or not CDS resource record, I mean, CDNS key is another thing, because you cannot signal what kind of digits type you want to have in the parent. Next slide. I think there's also opportunity to do something else as well. Have clients participate in the dry run with a wet run query flag. There are some bits available in EDNS next to the DO bit, but maybe more realistically, next slide, it's just the EDNS option acting as a flag. I hear Alexander moaning. Yeah. So both things cannot be tested with Wipe Atlas, so we have to look into other ways to see how backwards compatible that would be. Next slide. So you could sign your zone and not put a DS in your parent, and have your authoritative service report a reporting agent, right? So wherefore do we need the new DS algorithm to signal dry run DNSSEC? Well, because it's the extended DNS error reporting EDNS option is not transitive. A stuff resolver may not receive it. And so for stop validation, it's better if it can see that dry run is the intention by having access to the complete validation chain. Also, without it, you would not test the link to the DS record. And yeah, you would not have the benefit of those nice other features like bootstrapping actual DNSSEC from dry run DS. And yeah, when combining dry run with actual DNSSEC, it's nice that the dry run VS points to the keys that are intended to be dry run. So it's nice to be explicit about this. Next slide. So this is the ID, and I'm curious what you think of it, and if you believe that we should adopt it, if you think it's a good idea.
Yeah. We have a little bit of time for questions. Yeah, go, sir. Yeah, Gav, go ahead.
Hi, this is Gavin Brown from CentralLink. I think this is a useful tool in the toolbox, but I just wanted to flag a couple of issues on the provisioning side. So I can't speak for other implementations, but I can say on our side, we validate DS records which we receive over EPP. And one of the things we do is we check the hash length. And at the moment, every algorithm that's in a DS record has a corresponding fixed hash length, and this will make hash lengths variable because obviously if the dry run record is set in that algorithm field, then the implementation now has to know, I'll read the first bit off and then I'll validate the length of the hash. The second thing is the way that we as registries receive DS records. There are two interfaces in EPP. There's called the DS data interface, which this will work with completely fine. There's also the DNS key interface, where all we receive is the key data, and we generate, or the registry generates, the DS record. Yeah. And there's no way at this point, if a registry is using the key data interface, to know whether to set the dry run flag or not. So we'd need to extend that RFC, the EPP extension, to add a dry run flag that could be provided along with the DNS key data when adding a DS record to a domain in an EPP server.
Yeah, that sounds like a good idea. And also the first issue, alternatively, you could have a separate dry run DS digest type for each corresponding to the actual DNSSEC digest type. Shane.
Hi, Shane Kerr. So I was skeptical when I first read this, but actually when you explained it, it makes a lot of sense to me. Have you thought about whether it'd be applicable for helping measure the potential impact of like a root rollover?
I have not, but I'm doing it now. Yeah, I guess that would be helpful indeed. You could do a dry run. Yeah. Well, you would need a dry run trust anchor then. Yeah.
Yeah, I think especially if we're thinking about an algorithm role at the root, it might be useful to have this beforehand.
Yeah.
Yeah.
Well, we have thought about that dry run would be very useful for testing algorithm rollovers in just your own domain, but I guess.
Cool,
it might just, yeah.
Ralf Weber-Ackermann. So validation already is one of the most complex code pieces in a resolver. We are now adding complexity to that for kind of no benefit because you're giving out sort of insecure if you're encountered. And I think that we should be pushing EDE. Get clients to implement EDE and have that as a goal because that gives the end user a clear indication. And if you implement DNSSEC, you'll find these things. So I don't think that this is something that we should do, getting more and more complex stuff in the resolver to the point where only a few people can run resolvers because it's getting so complex.
Yeah. Yes, I think the most complex element of this is the extended DNS error reporting up to the operators, which has already been worked on in the work group. And the goal
you know my opinion on those.
And the goal is to give operators more confidence, right? That to give the operators more confidence that they're, yeah.
Well, for NL, half of the zones are assigned and it works. So
Yeah.
clearly it is possible if you put enough energy into it.
Yes, best would be if all TLDs would give out the domains cheaper if you do DNSSEC. That I agree.
Thank you. Benjamin, please go ahead.
Hi. I think this is a recurring pattern now of people trying to stuff things into fake digest types with in the DS record. Seeing as I wrote a draft to do it and you wrote a draft to do it, and we're not the only two. Rather than keep doing this for every idea that people have for stuffing things into the DS record, maybe we should have a general purpose meta digest type where we can then avoid polluting the digest type space with lots of different weird things that aren't digests. As to this proposal specifically, it's not my area really, but I do wonder, would we be better off just providing some best practice guidance about how to set up a duplicate of your zone in order to enable DNSSEC there, see that it works, and then do the same thing on the real one.
Thank you, Ben. Jaromir, sorry, we are out of time. Please send your request to the mailing list.
Okay. Thank you, Willem. Take it indeed, continue the discussion on the mailing list, and we'll go forward from that. Thank you. Next presentation is remote by Roland van Rijswijk, state hash-based signatures for DNSSEC. Yeah.
Thanks, Benno. Good morning.
Good morning. Morning, Roland.
I apologize for two things in advance. A, that my slides are much duller than the ones that Willem just showed with the beautiful pictures on them. And B, for my dog who has just walked into the room and might start barking if something happens outside. So apologies in advance. This is about a draft that Andrew Frickley from VeriSign and I co-authored on the use of stateful hash-based signature schemes for DNSSEC. Next slide, please. Maybe a little bit of context for that. So I'm sure you've all heard the discussion about the advent of quantum computers. Maybe Paul Hoffman has talked your ears off about this. And that there are varying opinions about when practical quantum computers might come to be around. But what there is consensus on is that these would break current public key algorithms and that this causes problems for internet cryptography. And we've heard estimations vary anywhere between 15 to 50 years, where obviously if it's indeed 50 years, we shouldn't really be worried right now. Whereas if it's 15 years, we might need to start scratching our heads. As a consequence, post-quantum crypto algorithms, PQC algorithms, are seeing a lot of development. Maybe you've heard of the NIST standardization effort, which is currently in the final phase. And there is also momentum to start deployment of PQC algorithms. There have already been a lot of experiments in, for example, in the TLS space. But because of this NIST standardization effort, you can expect requirements for PQC support to appear in government tenders in the near future. Because as soon as this becomes an official standard, governments are going to require manufacturers to support these algorithms. Next slide, please. But then there is the argument that DNSSEC signatures have an effective 0-year shelf life, right? So they don't last much beyond their expiration time. So why should we now already care about PQC for DNSSEC? Well, the answer that we have for that is that standardization, implementation, and transition of algorithms take a long time. And an illustrative example of that is the 10 odd years that it took, for example, to standardize elliptic curve algorithms from when they first appeared for use in something like DNSSEC from them actually being standardized in RFC and then implemented and availability. There's my dog. And implemented in, I'm just going to close my door, implemented in software. There are other challenges with the new, and I put this in quotes, PQC algorithms that are currently being considered for standardization by NIST. There are worries about their long-term security, which is precisely why they're running this standardization effort to figure out which of the proposed algorithms are actually secure for use. But they also have rather unfavorable parameters for use in DNSSEC. So that's something that is a concern for us. Because of the challenges with new PQC algorithms that are still around, but also because of the long time it takes to standardize algorithms for the use in DNSSEC, it is our belief, so Andrew and I state that we think that we need a safe fallback to be standardized just in case. And keep that in mind with this draft. Next slide, please. And what we're proposing is to standardize stateful hash-based signature schemes for DNSSEC. A very, very quick primer on stateful HBSs. They were first proposed by Ralph Merkle and are constructed using Merkle trees. I'm not going to bore you with all of the details. The takeaway is that they are considered to have very strong security. If you use a secure cryptographic hash function, basically they inherit the security properties of the hash function. And that there are actually some good security proofs for this. Their workings are very well understood. You're very unlikely to encounter cryptoanalytical surprises that suddenly break the security of these schemes. And they remain secure in the face of powerful quantum computers. I note that stateless hash-based signature schemes also exist. For example, Sphinx Plus is such a scheme that's being considered by NIST. Next slide, please.
Roland, are
yes.
you willing to take a question from the room?
Yes, Stephen, go ahead.
Stephen.
Hi, Roland. Stephen Farrell. So I think there's a problem with stateful hash-based signatures is that you have a finite number of signing operations.
I'll get to that. Is that okay?
Well, but the reason I say that is because I think it means safe is not the right way of describing the whole situation.
Okay, I'll take that. We'll take that on board. Okay, so maybe I should clarify that. When we say safe or secure, we mean provided that you respect the limitations of these algorithms. And indeed, the fact that you can only make a finite number of signatures is a limitation. I was about to get to that, so maybe next slide. This is a very, very, very simple picture of what such a scheme looks like. What you see on the slide is the Merkle tree that constructs the public key of the signature scheme. Underneath every leaf is associated with a one-time use public key. As Stephen pointed out, you can only create a finite number of signatures. That's because the private key is actually constructed as a set of one-time use private keys that you can only use to create one signature, and you should never reuse them. So basically, a signature is composed of a one-time signature using the one-time private key on the data that you're signing, and then there is an authentication path in the Merkle tree, which is the list of intermediate nodes in the tree that you need to reconstruct the root hash in order to validate the signature. And in this case, those are the red nodes in the Merkle tree. Next slide, please. As Stephen pointed out, you can only create there are limitations to these algorithms. You can only create a finite number of signatures with a signing key, as the private key consists of a collection of OTS keys. It is essential that you keep state for your signer, because if you reuse one of the one-time signing keys, this breaks the security of the scheme. And this is potentially a challenge for online signers and distributed setups, and I'll say something about that on the next slide. Another limitation is that signatures are very large. They're typically larger than 2.5 kilobytes per signature. but the upside is that the public keys are very small, in the order of 70 bytes. So for DNS, this essentially requires eDNS0 to transport signatures as part of a message, and arguably you need TCP transport or a different transport. So we are therefore not claiming that this should be a preferred option for DNSSEC, but it could be a safe fallback, of course, if implemented securely. And given the time it takes to standardize these new algorithms, we argue that we should start standardizing this now so that we have at least a safe fallback in place in case we need it. Next slide, please. Maybe a side step if you have online or multi-signer setups where you have multiple signers that need to create signatures independently, you can use a so-called multi-tree scheme for that, where you basically have a top-level tree under which you have different hierarchies that you can distribute among multiple signers. And there is more information about this in the draft. Next slide, please. So the draft status, the draft proposes how to use stateful schemes in DNSSEC. We currently include 3 already IETF standardized algorithms in the draft. So that's HSS, LMS, and 2 variants of XMSS. And the RFC numbers are on the slide here. This draft, we consider this draft sort of roughly complete in the sense that everything we would think needs to be in there is in there, but of course it needs review. And we are interested to hear, and I already heard multiple times from Benno that he's going to run a survey, or that the chairs are going to run a survey, so we'll wait for that. But whether there would be an interest in adopting this and moving this draft forward. I would say that the way we set up this draft is very comparable to how, for example, the EDDSA RFC is structured. So it really only contains the essentials of how do you use this algorithm in DNSSEC. And now that labs have done or will do, I kind of lost track of that, a proof of concept implementation of this in Unbound. I see Benno nodding, so I guess that's been done. Next slide, please. We're also considering some follow-up work. We're considering a draft on implementation considerations, which would look at interoperability, the trade-offs that you have if you need to use these multi-tree setups, parameter choices, transport considerations, etc. Although we do realize that transport considerations might open up a can of worms because that applies to much more than just the use of these signature schemes. I think that's the last slide. Next slide, please. Yes, now is your time for your questions. And there are some thanks to people who reviewed this draft on the slide.
Thank you, Roland. Gavin.
Hey, Gavin Brown from Central Link. So a couple of points. Could you give an indication of how much state needs to be stored on the signer if it's an online signer, and for how long?
Yes, I can. So the state that you need to keep is which one-time signature of private keys you have essentially used. So you need to track, and this could just be a sequence number where you store the sequence number of the keys. And for how much time, that depends. So one of the parameters, if you choose the parameters for the key, you basically determine how many signatures you can create with that particular key. And you would need to keep this state for the lifetime of the key. Does that answer your question?
It does a little bit, but obviously if you've got a combined signing key or something, then that basically means that your SEP for your zone has a finite lifetime, because if you use up all of the,
yes.
you have to roll your key before you get to the point where you've used up all the available leaf signatures.
Yes, and yes, you're correct, and that's obviously a challenge because there's a trade-off here. Now, so basically one of the parameters is the depth of the Merkle tree that you use. So obviously, as soon as you add another level to the tree, the number of signatures that you can create with that key doubles. However, your signature length will also grow, but in a linear fashion. And so every level of the tree adds one step in the authentication path to the signature. So that's linear, and then the number of signatures that you can create doubles. So you can create keys that can generate quite a lot of signatures. But obviously, this is not suitable for every type of zone. If you have a very dynamic zone, you're going to run out of signatures at some point.
Okay, and one final point. You described this as a sort of fallback in case quantum crypto comes along and everyone breaks everyone's algorithms. So the proposal in this draft is that we should implement this but not use it.
That's a good question. So what we are thinking of is that you might need at least a secure option for the root, or for, say, TLDs, where you have a slightly better understanding of how that zone is operated and how many signatures you need to create, etc. If I think of the, I don't know the number off the top of my head, it's 86 something, the RFC that sort of specifies which are recommended algorithms and which ones you probably should not use. This would not be an algorithm that you must implement, but it's something that you probably should try and implement, but you must be able to validate it. That's how I look at it. But yeah, that's a fair point.
Thank you.
Okay, Paul Hoffman. So we're a little bit short of time, so please keep your questions and answers brief.
Sure. So this is actually a comment. Roland, you said that you're also considering doing an implementation considerations document. I absolutely would not support adopting this spec in the working group until we have that implementations document in parallel. Given that you just listed a whole bunch of minefields and such like that, I think that, in fact, I think the implementations consideration should be part of this document.
Okay, thanks for the comment.
Right, Stephen Farrell. So in general, I think doing this would be a bad idea. Doing it now would be a really bad idea. So the problem with stateful signatures is that it creates a whole bunch of weird corner cases, and the NIST competition is likely to produce non-stateful post-quantum signature schemes in the next year or two. It would be a much better option to wait for those and never think about stateful signatures for DNSSEC, in my opinion.
I don't share your optimism, but okay.
Hi, Peter Thomason from the ESEC. You said that these signatures should be a safe fallback option, but not you're not planning for them to be the preferred or a preferred DNSSEC mechanism. So I wonder how you can have both at the same time. Let's say, for example, you need the fallback in place when in 20 years from now something happens with the post-quantum algorithms. Then you already need the root zone to be signed with these things. And if you already need to have that in place, then it would have to be supported on all resolver infrastructure and already, I guess, within a few years from now. So how does that go together with it not being preferred in the sense that you can avoid deployment? Maybe you can't, and then it would be kind of required to have it everywhere, wouldn't it?
Yeah, I think so. I think that might be conflating two things. So when we say that this should not be the preferred option, what we mean is that operationally it should not be the preferred option, right? So unless there is a very good reason to deploy this operationally, you shouldn't do that. The support for it, implementing support for it is a different matter. And because signatures effectively have a 0-year shelf life, you can deploy such a fallback option only when you really need it. So you should be ready to go to deploy it, but that doesn't mean you need to use it in operation. So there's no need to actually use this in operation for signing until you really need it because of the way DNSSEC works.
Okay.
Martin, I don't know how you did it, but you actually somehow skipped into the closed queue. So I'm sorry, we are out of time, so please send your comment to the mailing list. Thank you.
Okay. Thank you, Roland. Please, we continue the discussion on the mailing list, and your draft will also be part of the survey. Thank you. Next up is Donald. Eastlake. You want to run your own slides? We run your slides.
Sure, I can run my slides. Well,
Yeah.
if you give me control of your of the uploaded slides.
We do have them ready also, if you prefer.
Well, I mean, I could run yours, or I can, let's see, I can do.
Yep, there we go. So I challenge you to finish your presentation on the slides in 15 minutes.
I'll see if I can be quick here so that the last presenter has a chance. So this is about expressing communication service requirements in DNS queries. This is a 0.0 draft, so doesn't claim to be fully polished at this point. And so the goal is you can get answers back that depend on what, for example, you'd like a minimum latency connection or maximum bandwidth or the like. Wants to work through recursive servers, so things like meta RRs are not really appropriate, with no changes, of course, to the DNS on the wire protocol or messages. So, the only things that are survived through recursive servers, QName, QType, and QClass, and really QName is the only practical place to encode additional information you might want to encode. So there's already, people are well aware, this is a very knowledgeable audience I'm presenting to, I must admit, ways to encode things about the service or the communications protocol you're going to use. And if you can get different responses back, depending on whether you're going to be talking TCP or UDP, it seems reasonable you might want different answers based on the kind of quality of service you want. So these underscores are used in a number of ways these days. There's also the RLDH, restricted letters, digits, and hyphen labels, defined in 5890, which effectively, I view them as ways to change the interpretation of labels. So currently the only one defined is the prefix for internationalized labels that can be interpreted as having a restricted set of Unicode in them. And none of these the RLDH labels, I think, should affect anything to do with protocol on the wire or very special processing or security. So what sort of things might you want to say? Well, you sort of a coarse QoS might be useful, where you just ask for like minimum jitter or minimum packet loss or things like that, with reasonable values for other things. Or you might actually want to specify a more precise metric, where you say like a minimum acceptable bandwidth is some number of megabits or gigabytes or whatever. So the draft, as I say, 0.0 draft, has a specific proposed format for labels, and suggests they might start with QS-, following the RLDH format. And QS, by the way, happens to not be a country code, or it seems like it sort of stands for QoS to some extent. And then just have a hexadecimal encoding of TLVs, where you might just have one TLV or possibly several. And hexadecimal is not the densest encoding you could imagine, but it avoids case insensitivity problems with DNS and should be easily readable for debugging and other purposes like that. So what would an example be, what it would actually look like? So this is one which, according to the information currently in the draft, would be a request for minimum latency for example.com. So QS-, is prefix, happens to be that type 1 is coarse QoS. This is just 1 byte of value, and the value 0.8 hex is currently the value suggested in the draft for minimum latency. So QS-1108.example.com means I want an answer back that is minimum latency. So what kind of data are you getting back? Well, there's lots of different things, obviously, but one possibility, one would be a semantic address. It's an address that has not just the identification of a interface identifier, but also encodes some additional information about how to connect to that, related to routing or how to set the header fields or who knows what. So you might just be doing a quad A retrieval with quality of service specified and get back a IP address which has some additional information in the lower order bits. And one way you could use that is you could have seeing where your application does the DNS query, takes the address it gets back, and just makes a network connection. The application could be pretty ignorant of all this stuff and doesn't have to understand these things. And maybe the first hop router or something like that notices the special quad A, the IPv6 address, and does the right thing to get you the network connection with the quality of service that you are seeking. So, you know, how much you have to tweak? There's really no necessary change at the resolver end. What do you have to do at the server end? Well, you know, obviously you can, if you just want to test out your resolver or application or whatever to create these things, you can always just ignore this. If this is a prefix label in front of your domain name, ignore it by using wildcard. If you have a small number of values like these coarse QoS values or a few specific metrics, you could just have those as entries in your zone, whatever. But indeed, if you want to support more general QoS metrics where somehow it dynamically computes something about how to handle your connection based on more precise or complicated QoS things, then there's some sort of thing would have to get done at an authoritative server, perhaps calling some backend or other system to get some information. So this draft also creates a ANA registry for these R-LDH labels, which I think is a good thing and has its expert review and gives some suggestions to the expert and creates a registry for these service request types. I'd like to ask people to take a look at the draft. Certainly welcome any kind of comments or suggestions on the draft. And again, here's the draft name. And I'd like to ask if there are any questions or comments at this point.
Thank you, Donald. Ben, please go ahead.
Hi, Ben Schwartz. I'm going to, I think, say my standard thing, which is this sounds like a job for service bindings. So I don't find the idea of encoding the quality of service in the label very appealing. Although I think I understand where it's coming from. I think that if I were presented with this problem, what I would do is to say that each of these different quality of service labels is something that can be encoded into an SVCB record. So you query for the name, you get back a list of options, and those options can be tagged with an indication of what kind of quality of service you might expect from them.
That's certainly something I'll look at a bit, but that requires, of course, that the application know about this stuff. Whereas what's been expressed here, especially if you can use a semantic address, means you could have an application that is just given a domain name and application knows nothing about any of this, but it magically gets its network connection with the desired quality of service. Because when it gets the quad A that has something in the bottom bits that make that be a semantic address that causes the quality of service it wants.
Yeah, it seems like a little bit too much of a retrofit to me. If you think that kind of degree of retrofit is required, I think it would be valuable to understand a little bit more about what the motivating use case is.
Okay.
Thank you. Ulrich.
Yes, this is Ulrich from the Swedish Internet Registry. In my head, quality of service is a property of the network path. And
yes.
I don't know how the resolving paths might intersect with the network path, but there's absolutely no reason to assume that it does. And so I really don't see how this solves the QoS problem.
You mean the resolving path, the path by which the queries and responses are that resolve the DNS query? The quality of service on the DNS query has nothing to do with this is the idea is to get back information from the DNS.
But this query I have to send out to, make my network path do something. If I send that to some resolver somewhere on the internet, how would that make my network path better?
The idea is that the information you get back in response to that query would. And it might be able to do that even if it's just a query for an address by using semantic addresses. You could be querying for other things as well, of course, but the idea is that the information returned would be such as to make it either more likely or certain or whatever that you would get the quality of service you wanted.
Okay.
I mean, if you think there should be more information about how that would work or something, then that's a perfectly reasonable criticism of the draft. But I think it's possible that that would work. I don't know.
Okay.
Okay. Thank you. Thank you all. And well, please continue the discussion on the mailing list. Any other questions you have for the working group, Donald?
I don't think so.
Okay. Thank you. Okay. Our final draft presentation will be by Tiru. So, sorry?
Donald, can I stop sharing your slides?
You can, oh, I can.
Oh, you can do
Yeah, I can do this. Okay.
Perfect.
Thank you. Tiru, do you want to run your own slides or we do that for you?
Yeah, it would be great if you can run the slides.
Yeah. Okay.
To save time.
Yeah. Excellent.
Hey, good morning. Good morning, everyone. We presented this draft in the last two IETF sessions. Next slide, please. Yeah, this was originally unstructured DNSOP error page that was presented at several IETF sessions, and based on the feedback we got from the working group, this structured error page draft was being created. So the idea was basically to get a parsable JSON for the user and the IT troubleshooting, especially when there is DNS filtering, and the client displays or logs the JSON with its own UI. That's the background or recap of why this draft was created. Next slide, please. One of the major comments that we got in the last IETF was that don't introduce a new ADNS option, rather reuse the extra field in the ADE option itself. And that's the change we did in this version, was to introduce recast extra text field in the ADE option to have a structured JSON fields. Next slide, please. So as you can see in this figure, it's going to be the extra text field with the JSON attributes to indicate reasons why the domain was being filtered by the DNS filtering service. Next slide. Yeah, we had also updated the security considerations based on the feedback from the working group that the error page would be displayed only if the error resolver, encrypted resolver, has a sufficient reputation. And in the previous version of the draft, we had mandated encrypted resolver as a prerequisite for receiving and processing the extra text field. And we had also added text to make sure that this error page is going to be displayed in an isolated environment, just like captive portals, not to get confused with the actual content provider giving the content back to the user. And in case if the encrypted resolver is not trusted by the client, then only the host name of the encrypted resolver could be provided. That way, the client does not have to visit the error page pointed out by the C and R fields. So those are the major changes that we did to this draft. And next slide, please. Yeah, I think we have addressed all the comments from the working group, and we have been presenting this draft the several IETF sessions, and we'd like to hear comments and request for working group adoption.
Thank you. Are there any questions from the room, remote or in person? Rolf, please go ahead.
Not a question, really, more a comment. So this shows a good usage of the sort of extended DNS errors and what you can do with it. And I just want to say that we have an experimental implementation for that. And if somebody wants to work with us, I'm happy to work with them.
Thank you. Thank you. Tommy, you're next.
All right. Hello, Tommy Pauly from Apple. I just wanted to speak up to mention that I'm definitely supportive of doing some work in this area and solving it. On the client, we are seeing a lot of cases where there is filtering going on or blocking, and the signals are not explicit, and they often interfere with actually displaying a page if they're redirecting you to something, but your original connection is using TLS. So this would be a very useful mechanism I think the details may need to be iterated upon by the working group, but it'd be great to see this in the working group's hands and iterated upon there. Thank you.
Thanks, Tommy.
Ben.
Hey, my biggest concern with this draft, it seems like it's still there fundamentally, which is that this draft is at base meant to create a situation where the client ultimately opens a web page that is selected by the resolver, and that's just a really big change from the security posture that we currently have between clients and resolvers, even resolvers that we are, that are in some sense trusted. Even like a trusted recursive resolver program like Mozilla's does not allow the resolver to in any way direct the user to open particular pages or websites. That is the real point of concern for me. If we could find a way to keep this truly machine readable so that the information is presented by the resolver to the user agent, and then the user agent can figure out how to present that information safely to the user, that would be much more appealing to me.
Thanks, Ben. And there are several fields in this JSON structure, like the justification field, which is just a plain text and not an error page in itself. So the error pages are an optional text, and the human-friendly organization name or the justification text fields are purely machine parsable, and the user agent can display whatever appropriate error page it wants to display. The other fields are pretty much optional. So I think as a working group, we can decide which one is mandatory, which one is optional, and then make progress on this.
Sure. So yeah, if the draft could be clearer about what's optional here and focus on the machine readable components, that would be much more appealing to me. One way that you might pursue that is by replacing some of the metadata information with like a contact field, like a mail to link. If you need more information, here's the link to here's an email address to talk to tech support. Here's a phone number that you can call.
Sure.
Okay, thank you.
Thanks, Ben.
No other questions and comments. So Tiru, yeah, we were testing your patience. Sorry.
Not a problem.
We explained the procedure now for adopting new working group documents. So we will run the survey, and your draft will be surely part of that, of the survey.
Thank you.
Yeah. Okay. Thank you all. We come to conclusion of the working group. I would like to thank all the presenters of drafts. Thank you very much. I would like also to thank all the remote and in-person attendees here in the DNSOP working group. It's good to see you back here in the room. And I would like to thank Alexander for helping us out as a delegate. And that closes the working group. Thank you. For today. Thank you, Warren. The DNSOP working group is closed for today.
Yeah, but what I reproduce it.